Alright guys, we're going to work on graphing and solving systems of equations. So over the last couple of days we've looked at slope-intercept form y equals mx plus b, and you learned how to graph the solutions for the equation, a linear non-proportional equation that is in that slope-intercept form. Remember, the first step was to plot the point 0b, where the b is the y-intercept, and then from there we're going to use the slope to plot the remaining points and then connect the dots to make our line that shows the infinite amount of solutions for that equation, the xy solutions. So what we're going to do now is we're going to solve a system of equations where you're giving two equations in the form of y equals mx plus b. We have to graph both of those two equations and then find the point where they intersect to find the solution for the problem. So I'm going to walk you through how to do two of those examples and just show you how to do that. So let's go. So first one I have here is y equals negative x plus 3 and y equals x plus 3. Again, these are both in the form of y equals mx plus b, our slope-intercept. So here 3 is our slope-intercept, our b. Negative 1 would be our slope. In this one, 3 is our slope-intercept, our y-intercept, and a positive 1 is our slope. So let's go ahead and graph these. So I'm going to start with the point 0b, so that's 0, 3. So when x is 0, y is 3. And then I'm going to have a negative 1 for my slope. So down 1 over 1, down 1 over 1, down 1 over 1. And my line is going to run from there. I'm going to use this for my line. Okay? And now the second one. Again, I'm going to plot the point 0b, so 0, 3. I'm going to do this one in blue here. So 0, 3, again, is right here. And now I'm going to use the slope to plot the remaining solutions. So my slope here is a positive 1. Up 1 over 1, up 1 over 1. Rise, run. Rise, run. Run. So my line is going in that direction. So the point that solves this system of equations is the point where they intersect. So let's find that point. That point would be right here. So what we got to do is we got to read the graph to find where that point is. So it's on the y-axis, so x is 0, 1, 2, 3. So this point here is 0, 3. When x is 0, y is 3. So the solution to this system of equations would be 0, 3. So I would want to plug that in to check to see if that was correct. So when y is 3 and x is 0, are they equal? Well, 3 equals 0 plus 3. Is that equal? Yes. Let's try this one. When y is 3 and x is 0, is it equal? 3 equals 0 plus 3. Yes, it's equal. So the solution to this system of equations is 0, 3. When x is 0, y is 3. All right, let's look at another one. So I have y equals 3x minus 6. The first thing I want to do is plot my 0b. So that's 0, negative 6. So I'm going to plot that point where x is 0 and y is negative 6. And then I use my slope to plot the remaining points. So my slope here is 3 over 1. That's my slope. So I'm going to rise 3. 1, 2, 3. Run 1. Rise 3. Run 1. Rise 3. Run 1. Rise 3. Run 1. I'm going to, again, use a straight line here to help me out. Sometimes drawing a line is the hardest thing to do. Okay? So that is for this one, y equals 3x. So let's go ahead and plot the other one. Again, I got to first plot my 0b. My b is a positive 6. So let's plot 0b. 0, 1, 2, 3, 4, 5, 6. So that's 0, 6. Okay. And now I'm going to use my slope. My slope is here. I have a negative 1 slope. So rise, run, rise, run, rise, run, rise, run, rise, run. And I'm going to draw a line that connect those dots. So again, the answer to the solution to this system of equations is the point where these two lines intersect. So let's find that point. It looks like they intersect right here. So let's check the value of that point. So it looks like 1, 2, 3 for x, and 1, 2, 3 for y. So now that I've found my point, I'm going to input it into the solution to see if it's correct. So let's check this one. 3 equals 3 times 3 minus 6. 3 equals 9 minus 6. Well, is 3 equal to 9 minus 6? Yes, it is. Check. Let's check the second one. 3 equals negative 3 plus 6. 3 equals, so if I add 6 to negative 3, 1, 2, 3 to 0, 1, 2, 3 to positive 3, 3 equals 3. So does that accurately solve that equation as well? The answer is yes. So our point, 3, 3 solves both of these equations. So the answer to this system of equations would be the point x3, y3. All right, guys, go back and watch the video if you need more help. Practice, 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 and you'll be able to get it real simple. All right, good luck, guys.